if there are no questions on any of the assignments, we're going to go on and look at the lesson today. Golly. So the first thing we have is this here, is the square root of a negative number property. Now, this here is not a huge piece of, or a huge theorem or concept, because if r is a positive real number, negative 3, or sorry, not negative 3, 3. So if we say r is 3, then the square root of negative r is I squared of r. Okay, well, what one is saying is, well, if we have the square root of negative 3, well, we know the negative is going to come out as I, and we have the square root of 3, as we covered that last week, yes? Well, if that is true, then we could also say by the first property, then I square root of 3 squared is, well, negative 3. Because I squared is negative 1, and the square root of negative 3 squared is just going to be 3, so we have negative 3. That is all this property is saying. The square root of a negative number property, well, square root of a negative number is going to be I times the square root of whatever that number is. And if we square it, well, we get back to that negative number. Let's look at some examples of solving. X squared plus 4 is equal to 0. Now here we can use the square root method because the only variable we have in this equation is x squared. We don't have any variables with just x to the first power. So if I'm using the square root method, what was the first thing we needed to do? To get the x squared, or the term that's being squared by itself. So we would subtract 4 from both sides. These would cancel, telling us that x squared is equal to negative 4. Then we would square root both sides, because the square root of x squared, square root and square would cancel, leaving us with just x is equal to what do we have before it? Plus or minus. Now the negative is going to come out as, and the square root of 4 is 2. Because again, whenever we square root both sides, we have to have the plus or minus. Whenever we square root both sides, we need the plus or minus. Because really we're finding the number that goes in for x. And that number is being what? Squared, yes? As if the number is negative, well, negative times a negative is a positive times a positive is still positive. We need that plus or minus. Now, if we went the other direction and squared both sides, square root of x is equal to 4. If I square both sides, it's just going to be x is equal to 16, because the number inside of a radical has to be positive. If we go the other direction, we don't need the plus or minus. Any other questions on this here, or any questions on this here? 2x squared minus 11 is equal to negative 47. Because the only thing that we have is x squared, we can use the square root method. So we want to get x squared by itself, so we would add 11 to both sides. Negative 11 plus 11 is 0, leaving us just 2x squared is equal to then we would divide both sides by 2, which would just leave us with x squared is equal to Any questions on this so far? Then exactly we would square root both sides. The square root of x squared, well, the square root and square would cancel, leaving us with x, is equal to plus or minus. Well, the negative would come out as I, leaving us with the square root of, is 18 a perfect square? Well, no. It's going to be 3 square root of 2. Because what we can say is 18 is 9 times 2. 9 times 2 is 18. The square root of 9 would be 3. And we're left with the square root of 2. Now the yellow calculators, the TI 30XS, will simplify the square root of 18 into simplest radical form. It will do most of them. The only time it won't is if the numbers get too big, then it's going to convert it to a decimal. Any questions on this here? Any questions over anything we've covered so far? Let's look at the last one before we look at the next part. Find the zeros of f of x equals 4x squared plus 20. Well, if we're finding the zeros, we want to find where this thing is equal to what? 0. We're trying to find out what value of x will make this equal 0. Now, since x squared is the only term that we have, we can use the square root method. So we're going to get the x squared by itself. We're going to minus 20 from both sides. And if we do this, these will cancel out, leaving us with 4x squared is equal to negative 20. And what can we do next? Divide both sides by 4 so we can get x squared officially by itself. Because 4x squared divided by 4 would just be x squared is equal to now the square root of x squared would just be x is equal to plus or minus I square root of and that's it. Questions on this here? Now the square root method works well if we're able to have something in a set of parentheses squared, or we have just x squared. We don't have x to the first. Now this one here, x squared minus 16x plus 64 has a special property to it. Because if we look at this here, if I factored this as it is already, and we left the 100 alone, well, we would have 2 sets of parentheses with 3 spaces. Now finding the sign, since 64 is positive, the signs would be the same and match the sign of the middle term, which is negative. So these would both be negative. And lastly, we need to find the factors of the first and third term. Well, the factors of the first term would be x and what factors of 64 could we use? Because 64 would be 1 times 64, 2 times 32, 4 times 16, and 8 times 8. And it actually works out that this here will factor to x minus 8 times x minus 8. Wait a minute. Both of these here, both of these sets of parentheses are the exact same, yes? So I could rewrite this as x minus 8 what? Is equal to 100. This here, this x squared minus 16x plus 64 is what we call a perfect square trinomial. Perfect square trinomials, when factored, can be rewritten as a single set of parentheses squared, because what's inside both parentheses will be the exact same thing. Well, we have a set of parentheses squared, yes? By itself, so we can use what? The square root method. I could square root both sides. Because here, the square root and square would cancel, leaving us with x minus 8 is equal to plus or minus 10. So since I was able to rewrite x squared minus 16x plus 64 as x minus 8 squared, we could use the square root method, square root both sides, and then what? Add 8 to both sides, which tells us x is equal to 8 plus or minus 10. Can I add 8 and 10? Can we do 8 plus 10? Can I do 8 minus 10 and get a number? Yeah, we can add and subtract 8 and 10, yes? Because they are like terms. So if they are, we have to actually add them and subtract them. Well, 8 plus 10 is 18. 8 minus 10 is negative 2. If one of the two numbers, most likely the number after the addition and subtraction, is not an irrational number, we don't have the square root of 2, we don't have this radical left over, and it's not containing I or both, like on the last ones where we had plus or minus I square root of 5. If we had a number added or subtracted in front of it, we can't do that. They are not like terms. But here, 8 and 10 are like terms, so we'll need to add and subtract. Any questions on this here? Well, this is kind of helpful because if I can get it into a perfect square trinomial like this one here, then we can be able to use the square root method to solve it every single time. And really, that is the key to it. And the next way that we're going to learn is completing the square. Completing the square is going to be the first method out of the two that we will cover that works every single time on any and all quadratics. Now, one of the keys to completing the square is actually having a perfect square trinomial, being able to rewrite the trinomial as a set of parentheses squared. Now, the first equation we're looking at is x squared plus 14x plus c. Because if I can find a value of c that will make this into a perfect square trinomial, then we could rewrite it as a set of parentheses squared and use the square root method. Now, c that we need is defined to be as b over 2 squared. And again, it's just referencing back to the general form of a quadratic, ax squared plus bx plus c, where a is the number in front of x squared, b is the number in front of x, and c is our constant term. So if we want to find out what the value of c is, we are going to use this formula here. C is equal to b over 2 squared. Now, what is the value of b in this equation? 14. And it would be positive 14 because we have positive 14x plus 14x. Okay? Well, 14 divided by 2 is, and 7 squared is. So our perfect square trinomial would be x squared plus 14x plus 49. So the value of c that we're looking for is 49. Now we do want to write the expression as the square of a binomial. So just like on the last one where we had 8 minus x, or x minus 8 squared, that's what we want to rewrite this. Now we know that we're going to have x. Now we just need the other term. Now we could look at it, you don't have to write this next part down, because we would be looking at two sets of parentheses. We would have x and x. Since the 49 is positive, the signs would be the same and match the sign of the middle term, which is positive, so we would have plus and plus, because they're going to be the same. We'd look at the factors of 49, but what numbers would we use? And 7, which would just tell me that it factors down to x plus 7 squared. So we end up getting x plus 7, yes? Is there any other place where a positive 7 shows up? Right, we got positive 7 in here before we squared it, yes? It works out that x plus or minus whatever the number is will be exactly from there. So if it worked out to be negative 2 inside the parentheses before we squared it, well, we would have had what? X minus 2. It's going to be that exact number. And that's it for this here. Questions on this here? So when you do this on the homework, the two things they're looking for is this and that. They're looking for the value of c, which here would be 49. And the expression as the square of a binomial, a square of a two-termed polynomial, which would be here x plus 7 squared. Questions on this here? Well, this is nice because this here gives me the ability to take any quadratic and make it into a perfect square trinomial. I could rewrite any quadratic as a set of parentheses squared, which means any quadratic that we come across, we could use the square root method on because we're changing it into a set of parentheses squared every time. But before we get to that, let's find the value of c first and do this a few more times. For any of these here, c is equal to b over 2 squared. Now for this one here, what is the value of b? Positive 8. Well, 8 divided by 2 is, and 4 squared is, so that means our equation would be x squared plus 8x plus 16. X plus 4 squared, because again, the number that goes in there with x would be the number that we have before we square it. Any questions on this here before we look at the next one? All All right, so let's look at the next one. X squared minus 2x plus c. So we need to find the value of c. Well, c is still b over 2 squared, and here the value of b is negative 2. Well, negative 2 divided by 2 is negative 1. And negative 1 squared is? What is negative 1 squared? 1. So our polynomial would be x squared minus 2x plus 1. X minus 1, because the number inside the parentheses before we squared it was negative 1. All right, let's look at the last one. Now we want to find the value of c for this here, x squared minus 9x plus c. Now again, c is equal to b over 2 squared. Our value of b in this case would be. And what is negative 9 divided by 2? Negative 4.5. Yes, we get a decimal number. It doesn't divide evenly. Let's just leave it. Because here, especially when we start solving, having decimals is going to be a little bit more trickier than fractions. Because when we talk about square roots and finding these roots when we solve, well, finding the radical or root of a fraction is a little bit easier to work with than a decimal. As we saw last week where we took the square root of 25 halves, 25 over 2. But we can, okay, I can see that the square root of 25 is 5 over the square root of 2, and we can solve that out. Where if we're trying to find, so 25 over 2, well, that would be 12.5. Taking the square root of 12.5 is going to be a lot harder. So for these here, it's going to be easier if we leave it as a fraction. Now, when we square it, well, negative 9 squared is 2 squared is 4. So the value of c is 81 fourths. It is 81 fourths because we're squaring the whole thing. So that means our equation is x squared minus 9x plus 81 over 4. And as a set of parentheses squared, we have what? X minus 9 halves. Questions on any of this here? We're ready for the last two problems of the day. Now, completing the square has 4 main steps. And again, we'll be doing more completing the square and solving by completing the square tomorrow as well. The first main step is a equal to 1. Well, again, we're talking about ax squared plus bx plus c. So we're talking about the number in front of x squared. Is it 1? If not, make it so. If it's not 1, we need to make it equal to 1. Step number 2, get all the constant terms away from the variables and leave 2 spaces. Or in essence, get the constant term by itself. We want the constant term on one side of the equation. 3, find the value of c is equal to b over 2 squared and plug it in. Find the perfect square trinomial and solve, and essentially use the square root method. These are the 4 main steps in completing the square. So if we look at this first one here, x squared minus 10x plus 7 is equal to 0. Now the first thing we can do is see if x squared minus 10x plus 7 is a perfect square trinomial. If we could rewrite it as a set of parentheses squared. The 2 problems on your homework assignment tonight, 3 and 5, are already a perfect square trinomial. We don't have to do anything to them to get them to be a perfect square trinomial. We can go on and write them as a set of parentheses squared. Here, on the other hand, this one is not. X squared minus 10x plus 7 is not a perfect square trinomial. So the first thing we look to see is A1. Is A equal to 1? Well, yes, because A is the number in front of which variable? X squared. Well, there's not one written, so it's understood to be 1. The second step is to get all the constant terms on the same side. So we would subtract 7 from both sides. Because 7 minus 7 is 0, which gives us x squared. Minus 10x plus blank is equal to negative 7 plus blank. Because again, as a part of the completing the square, we want this quadratic to be a perfect square trinomial. We want to rewrite it as a set of parentheses squared. So what we're going to do is, again, we're going to use C, bless you, so that we can add it back in. So we can add it back into this here. Now, C, as we already said, is equal to B over 2 squared. And for this problem here, what is the value of B? Negative 10. So we'll take negative 10 divided by 2 is negative 5, and negative 5 squared is. So the value of C for this problem here is 25. Any questions on this here? So that means if we plug it in here, because x squared minus 10x plus 25 would be a perfect square trinomial. But if I add something to one side, we have to add it to the other side. Another way we could have added it in is on the same side of the equation. I could have added and subtracted 25 from both sides, because 25 minus 25 is 0. We're not adding anything. Or we can add it to both sides. Now the whole reason for adding 25 and finding it is so that I can rewrite the x squared minus 10x plus 25 as a set of parentheses squared. Now what goes inside the parentheses would be what? X minus 5. Because x squared minus 10x plus 25 would factor down to x minus 5 times x minus 5, or x minus 5 squared. Now negative 7 plus 25 would be 18. Any questions on how we got to this point here? Well, we do have a set of parentheses squared, yes? So that means we can use the square root method, which would be square rooting both sides. And here the square root and square would cancel, leaving me with x minus 5 is equal to plus or minus the square root of 18 would reduce to 3 square root of 2. And last but not least, what do we need to do next? Add 5 to both sides so that we do get x by itself. Can we add 5 and 3 square root of 2 without changing one of them to a decimal? Because what is 3 square root of 2? Well, it's 3 times the square root of 2, yes? So is 3 square root of 2 and 5, or yeah, 5 like terms? Well, no. There's no way we could add or subtract this without turning it into a decimal. So that right there is your answer. And the yellow calculator will tell you the exact same thing. Because if you type in 5 plus 3 square root of 2, it'll give you 5 plus 3 square root of 2. If you do it in the graphing calculator, it will give you a non-repeating, non-terminating decimal as the answer. But that's it. Questions on this here? Questions on anything we've done so far? This here is nice because so far up to this point, I mean, if it was imaginary solutions, we could do it by the square root method, which we saw today. But factoring only works if it's factorable. Graphing only works if it has whole number answers, or really whole number or nice decimal answers like 1.5 or a quarter would work well. If it's irrational or imaginary, it doesn't work for graphing because imaginary numbers don't cross the graph. It doesn't have an x-axis, so that doesn't work. The square root method by itself only worked if we had x squared by itself or a set of parentheses squared, which is we just saw for this one here. We had to actually make it be that way. And that's what makes completing the squared nice, is because now any quadratic we can turn into a perfect square trinomial, set of parentheses squared, and solve. We're going to look at one last one for today. This will be the last problem that we do together. So we're starting off with x squared minus 18x plus 5 is equal to 0. Now looking at this here, x squared minus 18x plus 5, that's not a perfect square trinomial. So we need to check to see, is a equal to 1? Yes. Now we need to get the constant terms on one side. Anything that does not have a variable needs to be on one side. Everything else needs to be on the other side. So if we had x or x squared on opposite sides, we need all the variables on one side, all the constant terms on the other. And what that leaves us with is x squared minus 18x plus blank is equal to negative 5 plus blank. And again, we're leaving two blanks for when we plug in the value of c. Once we find c, we'll plug it back in. Well, c is equal to b over 2 squared. And this problem here, what's the value of b? So we would take negative 18 and divide it by 2, which is? And negative 9 squared is 81. Is it that color? So we'd plug 81 into both sides so that we make it even. Now x squared minus 18x plus 81, we can rewrite or factor it down to x minus 9, because inside the parentheses before we squared it was negative 9, so it would be x minus 9 squared is equal to 76. Then what would we do next? Square root both sides. The square root and square would cancel, telling us that x minus 9 is equal to plus or minus 2 squared of 19. And last but not least, we would add 9 to both sides, telling us x is equal to 9. It's 2 square root of 19. And that's it. That's all we need to do for this here, and we're able to solve them. Any other questions on this here? Or anything else we've done today? Your assignment for today is on page 143, 5, 11 through 18. 3 and 5, we're using the square root method to solve. I will tell you already that the quadratic given to you is already a perfect square trinomial. We don't have to do anything to it to get it to be able to be rewritten as a set of parentheses squared. It's already there. Now, you can do the steps that we just did for completing the square to solve, and it will give you the same answer. You'll just find that when you move the constant term over, plug in the value of c, you're going to get back to the number you started with. So if the number on the other side was 100, you move the constant term over, plug in c, and add them on the right-hand side, you'll get back to 100. It'll get you back there. 11 through 18 is looking for two things. It's looking for the value of c and your set of parentheses squared. It's looking for both of those. And that